Hey everybody, we're going to be looking at inverses today. Inverses are basically the same idea or the same process that you did when you were solving for a specific variable. The goal here though is to look at it functionally with two variables. So we're going to be looking at it graphically and algebraically. Let's talk about some vocabulary really quick. So remember, vertical line test says, hey, if I have a function and I drop a line anywhere, it will touch the function at most once. Okay, now at most is important because over here on these left two, it's not touching at all. On the right three, it's touching it once. Okay, it's okay if it doesn't touch it at all. Horizontal line test, same idea, except we're going horizontally. Okay, again, I can touch at most once. Down here, not touching at all. Up here, touching one time. Okay. One-to-one function is a function that passes both tests. So this function here is one-to-one. I pass the vertical line test, I pass the horizontal line test. Okay, now again, sorry, my function is just not drawn very nicely, but it is passing the test. Okay, now the idea here too is, so for example, if I have something like this is a function. I can pass the vertical line test, but it is not one-to-one. Okay, because I'm failing my horizontal line test because here it would be hitting in two spots. Because if I inverted this function, it would look something like this. So again, failing the vertical line test here. So for a function to be one-to-one, it and its inverse must both be functions. Okay, so to test that, we do both tests. Okay, talking about this graphically, all we're really going to do is we're going to take x's and y's that we know, and we're going to switch the x and y. Okay, looking at this first point here, we've got -1, -2. So we're going to just change that to -2, -1. So -2, -1. Okay, the second point is 1, 1. So if I flip those, it's just going to stay 1, 1. Okay, this next point is 2, 5. So switching that, I'm going to have 5, 2. Connect the dots. And there we go. Okay, this is great when we know certain points and we have a graph, but for the most part, we don't usually have that. And talking about things algebraically or functionally is typically the better way to go. Okay, so I have a function here. I'm going to rewrite it from function notation to that y equals notation that you guys are used to. X minus 8. Okay, first step. Second step, I'm going to swap x's and y's. So I'm going to take all the x's and I'm going to change them to y's. And I'm going to change all the y's to x's. So x equals 1/3y minus 8. Okay, and then I'm just going to solve for y, just like you did on the last unit when you were solving for a specific variable. So I'm going to try to get everything away from y. So plus 8, x plus 8, solve for y, equals 1/3y. Okay, the reciprocal of 1/3 is multiplying by 3. So I'm going to multiply this side also by 3. And I get 3x plus 24 equals y. Okay, now I can just move those, that's fine. So y is equal to 3x plus 24. Okay, and then last up, I just need to put it back in function notation. All I need to do here is say the inverse function, so f -1 of x is equal to 3x plus 24. And I'm done. That's it. Okay. Most of these are not too bad. The last one is a bit tricky, so hang around for that one. I'm going to walk through these each one at a time. Okay. So again, same idea. Change it to y equals notation. to x minus 3 plus 5. Swap x and y. So x is equal to square root of 2y minus 3 plus 5. So we've got a little bit more going on here. Same concept though. I'm going to try to get y by itself. So minus 5, x minus 5, square root of 2y minus 3. So like in the last unit, to get rid of square roots, we square. If I do it to one side, I need to do it to the other side. X minus 5 quantity squared cancels 2y minus 3. Add 3, add 3. Now again, we're not adding 3 to this 5 because this 5, or says minus 5, is inside those parentheses with a square. Okay, so I need to leave it outside. That's fine. X minus 5 quantity squared plus 3. Those canceled. 2y. Divide by 2. Divide by 2. So y is equal to, and it's kind of looks a little gross, and that's fine. And then last step, remember, change it back to function notation. So inverse of f of x is equal to x minus 5 quantity squared plus 3 over 2. There's my answer. Okay, now depending on what version you printed out, this may not already be factored for you. If you had to factor this one, go check Ms. Heckman's video. She does go through the process of completing the square. I'm pretty sure everyone has the updated notes where it's already done for you. Okay, but same idea. Y is equal to x minus 3 quantity squared plus 4. Trying to get, or sorry, swapping x and y. Trying to get y by itself. So we're going to subtract 4, x minus 4 equals y minus 3 squared. Okay, get rid of a square, we take square root. Now I need to be careful here because if I do plus and minus here, like we've done in the past sometimes when we take square roots, if I do plus and minus square root, what that's going to do is it's going to produce this. Okay, and I don't want that, okay, because I don't pass the vertical line test. So I need to be careful here that I'm only using the positive or the principal square root. Okay, so x minus 4. I'm not going to put plus minus here. These cancel. Y minus 3. Add 3. Add 3. Square root of x minus 4. Now be careful with MathXL that you're putting this plus 3 outside the radical, because if you don't, it's not going to be happy with you. Rewrite it in the correct notation. Square root of x minus 4 plus 3. Okay, there's my answer. Okay, this last one is the tricky one. There's a trick to it. Watch carefully, pay attention. Okay, so anytime you have a rational and you have x's in the numerator and denominator, it's the same process. Don't worry, but I need to be careful on how I deal with it. So same process though. Y equals 4x plus 3, 3x minus 1. Swap x's and y's. So x is equal to 4y plus 3, 3y minus 1. Okay, anytime you see one of these, fractions are a pain to deal with. So let's get rid of it. We'll put parentheses around it. It's not changing anything. Times 3y minus 1. That's going to cancel these out. Now again, remember, if I do it to one side, I do need to do it to the other. So times 3y minus 1. Okay, I'm going to take this x, I'm going to distribute it to both parts. So x times 3y minus 1 times x, which is just x, equals, remember these canceled out, so I just have 4y plus 3. Okay, now here's the trick. Anything that has a y, I want to put on the left side. Anything that has an x, or anything else actually, I want to throw on the right side. Y is on the left, everything else on the right. So I'm going to subtract 4y. Okay, now I can't subtract these together because they're not like terms. This has an x term, this does not. So x 3y minus 4y minus x, these cancel, equals 3. Okay, now again, these two terms, first terms, have y's. That last term, the x, does not. So let's get rid of that x. Plus x plus x. So I end up with x 3y. Okay, actually let's rewrite that as 3xy. That's fine. Minus 4y, and then x plus 3. Okay. Next step we want to do, both of those have y's. That's really convenient. That means I can take a y out of both of those. For this first term, if I take a y out, I'm left with a 3x. For this second term, if I take a y out, I'm left with a negative 4 and a minus 4. Okay, well, multiplication's happening here. Opposite of multiplication is division. 3x minus 4. If I do it to one side, I need to do it to the other side. Okay, so here's where that trick comes in. If I factor out the y, everything else just kind of goes back over to the other side. These cancel, so I'm left with y equals x plus 3 over 3x minus 4. Okay, last step. Inverse of f of x is equal to x plus 3, 3x minus 4. Okay. If you have any questions, please let me know. Email me, send me a message on Canvas. Okay. These ones are the tricky ones. Okay. There are a couple in your homework, so be careful with those. Make sure you are doing them. Okay. Just as a reminder, you will test when and if we come back. Regardless, if we don't, we will still have a test on this unit. Okay. Expectation is that you are finishing everything before we come back.